Dear students, today consider another problems, a very easy and very interesting problem. Now we want to solve another problem. The problem is that if modulus of fz is constant, prove that fz is also constant. This is a problem. If modulus of fz is constant, then fz is also constant. This is our proof. Problem. Now we want to prove this problem. Since fz equal to u plus iv, we know this. Mod fz equal to root over u square plus v square. Mod fz whole square equal to u square plus v square. U square plus v square. But mod fz is constant, so we can write u square plus v square equal to mod fz is constant. This is constant. We consider c square. The constant is c. So this is constant. Mod fz. So mod fz, since mod fz equal to constant, so we consider this constant is c. This one given. Mod fz is constant is given. So we can write u square plus v square equal to c square. This is mod z square c square. So this is number one. We consider differentiating 1 partially with respect to x. We get, if we differentiating both sides with respect to x, we get del x u square plus del x v square del x c square. So this will be, if we write directly, twice u del x plus twice v del x, this equal to 0. So if we divide both sides by 2, then u del x plus v del x equal to 0. So we get this result is 0. Therefore we get, I rewriting this line, u del x plus v del x equal to 0. This is number 1 we consider. This is number 1. Again we differentiating this with respect to y. Differentiating 1 partially with respect to y, we get, if we differentiate partially with respect to y, we get, this is twice u del y plus twice v del v, this is del v del y equal to 0. So u del y v del y, this equal to 0. We get this are 0. Now we know Cauchy-Riemann equation. In Cauchy-Riemann equation, since CR equations, we know del u del x equal to del v del y, del u del y equal to minus del v del x. This is our Cauchy-Riemann equation. Using Cauchy-Riemann equation here, therefore u del y is minus del v del x, minus del v del x plus v del v del y. Del v del y means del u del x. So this will be del u del x equal to 0. So we can write in this way, v first, del u del x minus this minus u del v del x equal to 0. This is number 2. This is 2. This one 3 consider. First one, this is number 1. This is number 2 and this one number 3. Now we squaring this. This is 2 square plus 3 square implies. Now we squaring this squaring and this squaring and adding, we get I want to write here del u del x plus v del v del x this whole square plus v del u del x minus u del v del x whole square, this equal to right hand side 0 we get. Now this is a plus b whole square, this is a square plus b square plus twice ab, twice uv del u del x del v del x, twice ab, and this is a minus b whole square. This is the second formula in our life and this one first formula in our life. So this will be del u del x whole square, this is u square del v del x whole square minus twice uv, this is del u del x del v del x equal to 0 we get. So we get this. Now these two are like terms, this will be cancelled. So this will be cancelled. Now from this and this term taking u square common. If we taking u square common, we get del u del x whole square plus del v del x whole square. We get this. If we taking u square common from this and this, we get del u del x whole square, del v del x whole square. And from these two, taking v square common. If we taking v square common, then del u del x, first we write del u del x whole square plus del v del x whole square. Del v del x whole square, we get this. This one we get. Now again, these two are common. Then we get u square plus v square. This will be del u del x whole square plus del v del x whole square, this equal to 0. But u square plus v square is, this is c, it cannot be, this is constant, it cannot be 0. If it is not 0, then this will be 0. This implies del u del x whole square plus del v del x whole square, this equal to 0. It cannot be 0, but this must be 0 because their product is 0. This is a constant, u square plus v square is constant c. It cannot be 0, but this one 0. Now this is number 4 we consider. Now we know fz equal to u plus iv. So fz equal to del u del x plus I del v del x. By formula we know this. And f there z bar, this is e bar, then this I will be minus I. This is conjugate of this, just replacing I and putting minus I. So if we multiplying these two, now if we multiplying these two, f dash z into f dash z bar, then if we multiplying, then this will be del u del x plus I del v del x into del u del x minus I del v del x. We get this one. So if you multiply, we get this one. But this left hand side, fz, fz bar, we know this formula. In case of complex number, z bar equal to mod z whole square, you know. Z bar equal to mod z whole square. So this, if we assume z, this is z bar. So this will be mod fz whole square again. And this is a plus b, a minus b. So this will be a square minus b square. A square minus b square you get. And I square means this is a plus b, a minus b, a square minus b square. So I square means minus 1, so this will be del u del x whole square. I square minus 1, this minus minus plus del b del x whole square. And this value we get 0. So this will be 0 using 4. Using 4 we get this result is 0. Now what we get? At last we get f dash modulus of f dash z, this equal to 0. So f dash z equal to 0. So f z equal to 0. And this is d dz of f z. D dz of f z equal to 0. So if we integrate with respect to z, this is dz. If we integrate with respect to z, dz, this is 0 dz. So this will be dz cancel. Integration fz means d fz, this equal to 0, and this is fz equal to constant. This is constant. Now this is our proof. So we get, this is the proof. So what we get? We write details. Actually from this we can write this is constant. But if we write details, then we get mod f dash z equal to 0. Then d f dash z means d dz of f z, this equal to 0. And if we integrate with respect to z, then we get this. Then integration dz equal to 0. And if we integrate dz means d of fz means fz equal to constant. So this is our problem. If modulus of fz is constant, then prove that fz is also constant. So hence proof. Hence proof. So this is our proof. So dear students, the proof is very easy. If this proof is easy, then please subscribe my channel, like this video, and do not forget to click the bell icon. Thanks.